All right, we're finally into page 4, dealing with conic sections. So again, the key is you do need to know that what type of equation you're dealing with. So here we are dealing with a quadratic, so a single variable squared, versus the next equation has x and y squared. Now that could be an ellipse or a hyperbola, but the giveaway is that there's a plus sign between these two, which means it's an ellipse. Now, the equations in these standard forms, that's what these are, standard forms, have within them the numbers mean something. So the 3 here, now you guys remember have these equations on the final. 4p equals 3, that is 4p sitting right there. Whatever number is factored out of the right-hand side of the equation, it's the equivalent of 4p. That means p is 3/4, and remember in a parabola, that 3/4 is a big deal. It is given a vertex that is h and k, in this case -4, -2. That's what you're seeing on this. It doesn't ask you to plot it, but the vertex itself is at -4, -2, which you're seeing right there. You're supposed to find then from that vertex, you're going to go 3/4 units in a particular direction to find the focus. Now, this is a parabola. Since y is squared, it opens left and right, as opposed to when x is squared, it opens up and down like a traditional parabola. But when y is squared, kind of goofy, you want to move left and right, and a positive p means it faces to the right. That means your focus is to the right of the vertex. So if that's my vertex marked in red right there, my focus then is to the right 3/4 unit, which I'm marking in blue. So in blue, that's the focus. And then from the focus, you can go 2p up, which is 3/4 and 3/4, or 1.5 up and 1.5 down. And to get 2 more points on that parabola to give you a sense of width of that particular parabola. And then p units to the left is the location of the directrix. And the directrix is a vertical line. In this case, when the parabola faces left and right, it's a vertical line. If it faces up and down, it's a horizontal line. It's like a steering bar. It has cool properties related to that particular parabola. But given the information we have, because this opens left and right, y is squared, p is 3/4, which is positive, you're going to go to the right 3/4 units from the vertex to put your focal point. 2p up and 2p down will give you 2 more points on that parabola. If you go to the opposite direction, p units, you'll get to the directrix. I want to draw that line. The things that you want to be able to identify are the location of the focus, just coordinate point wise. The directrix is a vertical line, x equals 4 and 3/4. The next equation is your ellipse, and in the ellipse, the underneath x is 9, which is 3 squared, which means left and right from a center on this ellipse, you're going to go 3 units, and then under y is 4 squared, so left and right, up and down from wherever your center is, you're going to go 4 units. The center of this one, if you want to think of it, is x minus 0 squared, and this could be y minus 0 squared. So the x in the center is 0, 0. Now, that's to prepare you. Remember, usually ellipses have a center that's not 0, 0, for the problems that we've seen anyway, but this one happens to be 0, 0. And then that 3 units left and right and 4 units up and down will be from the center of 0, 0. And then you can sketch your ellipse. So that's a little sketch you've got there. The one piece you need to go calculate is the location of your focal points. Now the focal points are along the major axis, the longer of the 2 axes. So it's going to be on that blue line there. It's just finding how far it is, and the way it works is it's a Pythagorean relationship where the biggest dimension squared is equal to the sum of the 2 smaller dimensions. And dimensions are, in a ellipse, you're going to have c, the distance to some focal point, you're going to have, and then a and b are going to be distances from the center to the respective vertices. So it's going to be 3 and 4 that we found already. Now, in here, the distance, the focal point is somewhere inside the ellipse, and it's going to be smaller than the 4 units it takes to get from the center to the major vertices up and down. So for this one, your biggest dimension is going to be 4 squared, and that's going to be equal to the sum of the smaller 2 dimensions, which will be c squared and 3 squared. So that's why its biggest dimension squared is equal to the sum of the two smaller dimensions. Then you go about solving. You get 16 is c plus 9, or c squared plus 9, and then you get c squared is 7, and you take the square root of both sides. C is the square root of 7 plus or minus, like you know when you introduce a square root. But what it means is you're going to go from 0, you're going to go up square root of 7 and down square root of 7. And square root of 7, is, I think it's 2 point, I'm sorry, it's going to be a little bit bigger. Let's think of, to get to 4 is 2 squared, to get to 9 is 3 squared, so it's 2 point something. So it falls in there a little bit bigger than 2, and you plot the points, and you can find the square root of 7, I think it's like 2.6 or something like that. But just find a place to plot it in there, and don't have to be terribly accurate about it. Major axis is the longer of the two distances across the ellipse, and the length of it is 8 in this particular case. Alright, so I'll get to the second part of the video in the next recording.